61 2, clear takeoff, left hand. Takeoff left, middle land, swim west, copy.
Hello and welcome to the Blueskies podcast. I'm PR Ganapati, your host.
Just 70, roger, report type southeast, connection, for the midway, and field selected.
In this episode, I'm really happy to be able to interview a past guest of the program, Wing Commander PK Raveendran, who you would recall trained as a flight test engineer at Epner in France and then participated in a lot of flight testing throughout the Air Force. Wing Commander Raveendran was then selected to participate in the LCA program as a flight test engineer, and that's where we're going to pick up the threads with him, and I'm sure you're going to enjoy this conversation. So if fast forward a little bit, sir, you've had a very fulfilling career in the Air Force, and then Marshal Rajkumar called you about the LCA project. What was that initial call like, and what was your thinking when he invited you to join that program?
See, my last posting was Sulur. From Tezpur, I got posted to Sulur. Sulur, I was a senior most wing commander there on the sensor station, and I was in charge of HS7 for Diabro Check 2 service. It's a mini major kind of a thing. Okay, so then by then I missed my rank also. I didn't sort of make it to group captain rank. I was seriously considering quitting. Okay, leaving. That's a time, I got an offer also. There was some feeder airline, some Span Aviation, something started coming up in Pune. And they said, okay, we are looking for somebody like you. You maintain our aeroplane, fly as much as you want. I thought nothing better than that. But seriously, because my license was current at that particular point. I had a commercial pilot license by then. And Dr. Ramchand actually sort of, supported and, my, flying kind of a thing. Anyway. Okay, so then I got this call from Air Marshal Philip Rajkumar. He was in Delhi at that time. So he said, I am starting something what is called a National Flight Test Center to flight test this thing. I want you to join me as a lead flight test engineer. So I said yes, sir, and then I landed up. I didn't think.
Right.
I never regretted that decision.
Right. Besides both of you being from Epner, he must have also served together, right? I'm sure.
Yeah. When I came back, he was an ASTA. Then I served under him in test pilots school.
What stage was the project at when you joined NFTC?
In 1995, I joined. By then, there was already a small team in place. Okay. And we used to see that, so many days for first flight, everywhere this way. Okay. But at that, there was some kind of a pressure and, very, very aggressive kind of a schedule. And this initial team, they were sort of, working very closely with the control log team at that particular point.
Okay. Uh-huh.
Yes, there were pilot sourced from the Air Force, 2 pilots from the Air Force and 2 pilots from the HAL. Then there were some scientists from ADA attached. Then we have 3 functional entities, and let me see. There is a flight test operation, there's a flight test engineering, and then flight test instrumentation. So initial days, the flight test operations handled by flight test engineers and flight test pilots. Okay, and the initial days, the instrumentation, both onboard as well as the telemetry ground segments, were handled by HAL flight test instrumentation. Okay, but progressively we took it over, and NFTC took it over, and then it was it was under me as a group director of flight test. Okay, the initial set of test crew, they spent a considerable amount of time interfacing with the controller team, headed by that time, Srinath Kumar, venerable, fantastic guy. So under him, the entire controller team was working, and the flight test engineers, test pilots and flight test engineers at that time, they were interfacing the controller team, giving them basically that this thing was a fine-tuned handling qualities. Okay.
Right.
And this was done on various simulation platforms. We had ELS, Engineer in the Loop simulator, then RTS, it's called real-time simulator, which was in ADE. And later they even they validated these things on IFS. IFS is in-flight simulation, which is a Vista platform. Vista is F16, X16 modified. Okay, that means the front pilot can fly the aeroplane which you want to fly. That means you are, like LCA controller, you could port it on that, and the front guy flies LCA. The rear guy, in case something happens, the rear guy can take over and land it as
As an F-16.
So
Wow. Just boggles the mind when I think about that. These were all done in the US, isn't it?
Yeah, absolutely. It was done yes. And these excellent flying qualities, the Tejas. Tejas has a record of the maximum number of test pilots flying the aeroplane during the development stage. Okay, and everybody, I think I have spoken to most of them. They said the best aeroplane we have ever flown. The flying qualities was the real, the USP of that aeroplane. So that bears testimony to the excellent quality of professional inputs which has gone into the development of the control law.
And especially since a lot of them came from the Mirage, which itself is very highly regarded for its handling qualities, isn't it?
No, actually, the NFTC had the benefit of people from various backgrounds, So, various backgrounds, various types of airplane of different nationalities and all that. So, we could get the best input from everyone and integrate, yeah. So that was a real this thing. Everybody has given their bit, and that's how it has come out as one of the best aeroplane, which our air chief Jotu Baduria himself says this is the best aeroplane in the class.
No, he was very closely involved also at that stage, I think.
Absolutely. He is, the kind of push he has given at various stages, this thing is amazing.
Now, a lot of the things that you developed, instrumentation, telemetry, you built these yourself from scratch instead of just buying stuff off the shelf. Is that right?
Absolutely. See, initially, we had some kind of a system to start with. Okay, our tracking antenna, etc., was supplied by ISRO. Okay, then we had PCM decom system, they call it, for handling the flight test data. So all that we upgraded over a period of time.
Okay.
So see, the kind of preparatory work which were done initial days was, first task was we used to sit with the designers, okay, design group, to get their flight test requirements. Okay, these flight test requirements we converted into test points, and that test points gets into a test point database. Okay, and also we used to take the parameter requirement from them, and that goes as an input into instrumentation requirement.
Right.
And then we were preparing draft flight test schedules for engine ground run, a low speed taxi test, and high speed HSTT, high speed taxi test. Okay, then preparation of telemetry SOP. Telemetry, we need a standard operating procedure for the whole telemetry, so we have to make a document. And we also made a communication protocol document. Communication means who will talk to whom, who has got the priority, who, only test director will talk to test pilot. Okay, none of the monitoring guys can talk to him directly. If there is a problem, he only alerts me, and then if there is a serious enough problem, then I take over his page, and then if there's if there is a safety issue involved and something building up, then we have to recover him very quickly. That kind of action is taken. Okay. Then design and implementation of system-wise monitoring screens. That was another task which you have taken. And finally, the training and clearance of monitoring personnel. No, we didn't have the luxury of these flight test engineers in sufficient number to man all the screens. So we were using the designers. For that. Okay, they know everything about that, but then they are not used to this high pressure environment of flight testing. So,
Right.
so we had to give them special training, and then we had to clear them specifically, because they should not panic when something happens and all that. Okay.
Now, for the audience who don't understand what this means, it's a bit like space shuttle control in Houston, where there are
Yeah,
many
absolutely,
screens, many
absolutely.
people,
Yeah,
each one is monitoring their own system.
absolutely.
So just
This,
describe that a little bit for us.
yeah. See, test director, in the modified kind of this thing, he's sitting on an elevated platform, and he's supported by all these system monitoring personnel, each one very closely monitoring his or her system. Okay.
And by system, just what do you mean?
System means an aeroplane has got different systems, like aerodynamics. It's not a physical system, but yes, aerodynamics. All the parameters coming out of like airspeed, altitude, these kind of thing. Other one, like engine, propeller, propulsion system. That's one system. Then you have electrical system. There are electrical power sources on the aeroplane, like generators. Okay. So electrical is another system. Fuel, hydraulics. Then ECS is environmental control system. Okay. Then armament system. Then your avionics. Okay. A communication system. Each one is a system, no? So to be sort of closely monitored,
So
because
there's one dedicated person, their screen, they're just monitoring
absolutely
hundreds of parameters about that system.
Absolutely.
And this data is coming via telemetry, right?
It's coming via telemetry to the ground station. There it is processed and then pumped up to the telemetry monitoring group. Then there are a number of things, because I was there on this program for good of 20 years. Okay, so quite a lot of things I could do. One was we also got this lead time, no, because we had these aggressive schedules projected. So that lag was sort of we could utilize it for doing various things, like we updated our flight test techniques. Okay, so this is a very, very interesting work which we have done in the initial days. We developed a GPS based method of air data calibration and flow angle sensor. Flow angle sensor means angle of attack and side slip. Okay, a calibration using onboard iron system. This was never done before. So we developed this in a joint project with between NFTC and ASTE. Okay, it was done on a Jaguar. So within one acceleration, you could get the complete air data calibration for the covering the entire the speed range. So it was not done before. No, so this was a real solid upgradation of our flight test technique as far as the air data calibration was concerned. Okay, so like other one is upgrading the telemetry monitoring room, telemetry tracking antenna, which I mentioned to you, antenna itself. Okay, then we developed state of the art mobile telemetry stations. Mobile telemetry, that means like a scaled down version of what you see in the normal telemetry. You design and then package the whole thing on a mobile, like on a Leyland truck, and there you can do the same thing. You can drive this particular thing to outstation location. We have to go to outstation location for environmental trials and weapon trials and all that. No, so this mobile telemetry is to be driven to that location, and then we also established fiber optic connectivity and satellite connectivity of the data from there. No, and we at some stage it was like aircraft could be flying maybe say Jamnagar or wherever, but you could sit and monitor everything in Bangalore.
Oh, wow.
All the entire data is coming through fiber optics or satellite. Okay, so these kind of things we could do, and that is why we developed one of the best telemetry available in the country. Okay. Okay. Then we also established what is called a SBTF in Goa. SBTF stands for Shore-Based Test Facility.
Right, correct.
Okay.
That's for the
So
naval
it was
LCA.
it was naval LCA could utilize that, because yeah.
Now, you designed that whole thing yourself, or was it?
SBTF had very specialist kind of a thing. SBTF is basically a replication of what we had as far as the flight test monitoring was concerned. Apart from that, we had that ramp takeoff and arrestor. Those were not done by me per se, no. But only the data from there we could capture and then pump it down. It was all done by some dedicated, some contract with some, maybe Russians were involved in that. And all that, no? But when it comes to taking the data from there for analysis purpose, that particular bit was interfaced by us. Okay, yeah. Then we also developed something called eye track. Eye track is when the aeroplane is flying in a sector, the lat long and the height of the aeroplane is available on the through telemetry. It comes to monitoring station. No, so we had a scan map on this small aeroplane that will show the position of the thing. So I still remember an interesting thing. So I used to when these people are approaching the boundary or the sector boundaries, I used to tell them to turn around and all that. So ATC, those days there was one Mr. Iyer. Iyer used to monitor this thing. He was very curious. One day he asked me, Ravi, do you have a radar? I said, yeah, I have a radar, but not the type you have and all. So he came to see this. So when he saw that, he said after that he went back very satisfied that okay, LCA is in safe hands. Okay. Then we also, one more thing which we did was we developed a GPS based radio sound. What is radio sound? For some special tests, we need very accurate upper air data. Okay. Earlier days, this upper air data used to come from the what do you call India IMD, India Meteorology Department. Okay, and they had a very antiquated kind of this thing. They used to radio sound. They used to release it and all that. And they used to try to track it with radar and all that. It is a very messy thing, and it never used to be available. So we developed what is called we put a small GPS sensor in that. Okay, in a radio sound, and sensor and all to capture the pressure, the temperature, and release it, and with a small transmitter. So as it ascends, it gives you position and this thing. So you are not dependent on. And this particular GPS, it won an award, Aeronautical Society Award for indigenization. So yeah, and Mr. David, he's the one who has done it. I have given the scheme, so and he's the one who. So we both shared that Aeronautical Society Award for indigenization.
Very interesting.
Visual show before just 70, Roger, report type southeast, connection, for the midway, and field selected.
You've shared with me the video of the first flight. I think at this point, maybe it's a good idea for us to just listen to the audio of the first flight, and for YouTube viewers, they can also view the video of the first flight.
Confirm trains are neutral.
Neutral.
Okay, last check of controls.
Neutral, straight open top.
Okay, going to IRP. Okay, waiting for roll call.
Clear to go. Roger.
Rotating. And climbing up.
But you were in the control station at
I was
time,
the test director.
So
and,
just tell me, the preparations leading up to the first flight, the day of the first flight, what did it feel like? And when you gave that clear for takeoff signal, what was going through your mind? What were some of the feelings?
See, we had a lot of time to prepare, because time was, So, and it was thoroughly prepared. We didn't leave anything to chance that way. Okay, and leading up to first flight, we had a number of reviews like safety review, system safety review. Then we had what is called FRR, FFRR, first flight readiness review. Okay, these are all, anybody can ask any question to anyone, and till such time get a very satisfactory answer, we don't proceed. That whatever we could possibly think of, we have sort of raised these issues, and then we documented and then try to find solution to any eventuality, that kind of thing. So we had thorough preparation. Then we had before going for first flight, we had what is called a what if session. That means, what if this happens? That kind of thing. Anyone can say, anyone can ask, what if this happens? This is to be done. This is to, this happens, or this to be done. So that way, we have, and also the first flight profile was flown in by number of times. It was flown in RTS, real time telemetry system, and we checked out. And after the first flight, even the fuel recordings which we got from this thing was absolutely matching the first flight. To that extent, it was rehearsed, and it was absolutely truthful kind of a reproduction of this thing. Okay. Then we have this. I told you about the communication protocol was set up, SOP we have put in place. Then we had a very well laid out procedure for going for this. For each flight we prepare a schedule. Flight test engineer prepares a schedule. It's coordinated, signed by the test pilot also, and then coordinated by the certification.
Mm-hmm. What is the schedule like? So what sort of information?
Schedule means it will contain all the test points. Okay, you starting from checks and startup checks, and then everything is there in that.
This runs
And
into
then,
how many pages? This is
no. Actually, it's about 1 or 2 pages only.
Okay.
But not details. Details are available elsewhere. But you make the schedule, and then it is briefed. The schedule is briefed on the day of the flight. Briefing is done by the test director. Okay, and test pilots covers the safety aspects also in that, and along with the what do you call it, the chase. If there are some aeroplane, so some tests will have chase aeroplane, no. So the chase pilot also is in attendance. Okay, so that is how. Then we move to test director moves to telemetry, and test pilot goes to the aircraft. Then the flight test process takes place. Okay, each test point is specified. Then it is monitored in the telemetry. If there is a and then you give him the clearance. Like for example, there are some tests like Flutter tests, etc. It's very. I'll come to that case.
Yeah, no, I want to understand what is Flutter
Yeah.
tests.
Anyway, then immediately after the flight, we do what is called a hot debrief. Okay, everyone moves to the briefing hall, and each individual who has taken part in this, he gives his first impression of that. That's called hot debrief. Okay, then we disperse. Then earlier it used to take a day or this thing. So then data is prepared and analyzed by the designers, and then we have what is called data debrief. That's a very very detailed briefing session. In the data debrief only, we decide whether we can go ahead with the next flight or not, or is there any serious issues to be addressed. So, and whatever observations from the flights, it gets converted into what is called RFAs. RFA stands for request for action. That means if there is an observation pertaining to one particular system, it gets recorded in an RFA, and it is passed on to that system group, and they have to give a solution to it. Then NFTC can only close that RFA. Okay, once we are satisfied that particular issue has been taken care of, then we close that RFA. So this RFA thing came as a very very good aid for the certification guys also. So they were the stage came, they used to ask the designers, how many NFTC RFAs are pending? You close all that, then we will clear your item. That kind of thing. So we put some very good system in place. So it is working well. Yeah.
Okay, so coming back to the first flight, You walked to the aircraft, started up. What was going through your mind? What were your feelings?
See,
Were you
once
nervous? Were you excited?
not really. See, once you sit there, because we have been through this process, except that he has not taken off. You understand
Right,
what I'm
right.
trying to
You've
say?
done
This
the
particular
high-speed
procedure,
trials and
yeah. Once you're sitting there, but then you get into that routine. I won't say routine, because I am dead against using the word routine for flight tests. So I don't. Okay, so it is like any other operation. So okay, so there is no other time to think of anything else, and then you are glued on to the thing. Yes, you must be aware. Air Marshal Rajkumar has written, because we unfortunately we lost the telemetry link.
you had telemetry loss,
Yeah,
and so
the
just tell us
telemetry
about
link.
that.
What
Yeah.
happened? Yeah, that reason was very very funny. But what has happened was, this. There are some stealthily somebody was using our frequency, and the moment aeroplane took off, our antenna swung to that, and we lost the link.
So yeah, for the audience who don't understand, a telemetry antenna tracks the aircraft, and because somebody else, there was a software technology park, I think, that
That's
was
right. Yes,
broadcasting the
yes,
same frequency.
yes.
So your antenna turned towards them, and obviously, this is first flight. Must have caused a lot of nervousness, but you
Yeah, it was the
confidently gave him the thumbs up to continue because
yeah. Air Marshal Rajkumar was sitting there, then also next to me. Then he. We Nambiar was flying the Mirage, so he closed in and then started, monitoring very closely from external kind of thing, whatever he can, and then provided this thing, and then we decided, because the whole flight was about 18 minutes, and then again when we was coming back for landing, we got the telemetry link back. Okay, so that is how it is. So that was a bit of a letdown from the yeah.
But so tell me about Flutter testing. So what is Flutter? What is Flutter
Yeah,
testing?
Flutter. Yeah, okay. You see, flight flutter it's an aeroelastic phenomena, okay, of structural response to inertial, elastic, and aerodynamic forces in flight. Okay, what happens is, your structure, aeroplane structure has got everything, has got a mode, no? Like you say, if you knock on your table or something, it makes some noise. That means it's vibrating at a certain some natural frequency. Likewise, aeroplane as a structure, it has got a various modes. And these modes, we can understand the what do you call. We can get the details of the modes by what is called a GVT, ground vibration test. Okay, so structural modes are known, and the structure has got certain frequencies, certain modes and frequencies. Okay, and it's got structural damping also. Each structure has got a inbuilt damping. Okay, and these structural vibration characteristics are a function of stiffness, mass, inertia, and all that. Okay, and now once it's get airborne, what happens is now aerodynamic force comes in. Okay, now there is an aerodynamic damping coming in. Okay, now there are two ways that this damping can happen. Either this damping can aid structural damping, or it can get out of phase with it, in which case it will go divergent. Okay, so it is one of the riskiest and at times very dangerous, see. Okay, uh, so it is part of an envelope expansion test. Envelope, when you say, it is an aeroplane has got a flight envelope. Flight envelope is in terms of height, altitude it can go, speed it can cover, Mach number it can cover, angle of attack it can cover. Okay, like that envelope. So the loads etc are dependent on envelope, no? Like higher the speed, higher the load, and all that, no? So these the idea is to see that your aeroplane is free of flutter in the envelope which you are clearing. You get my point? So you start with a lot of this ground test analysis, etc. Okay, then do simulation, and then you have an idea whether your flutter envelope is outside your clearing, and the envelope you want to clear. But then you'll have to validate, verify it through flight test, isn't it? So this flight test is, very very gingerly we approach this flight test. Okay,
Why is
each
that? What does the pilot experience? Or
see, the thing is, this fly-by-wire machine, see, to excite the flutter, the olden aeroplanes, we used to have some bongers, etc., to excite. Okay, there are various methods of exciting this thing. It was very very cumbersome, but this is fly-by-wire machines got an advantage. You have the closed loop control system, no? And through that you can inject the excitation signals. Okay, so that is also, you have a series of excitation signals programmed and then loaded on the aeroplane. And at the set, that particular condition set up in terms of altitude, Mach number, etc., we give clearance for him to select that particular signal and then inject through that. The moment you inject through that, it lasts very short, very small time, no? And then we have set up something like a quick look kind of a thing, no? In the available data on the telemetry, you have a look at the frequency and damping parameter as a function of the Mach number. And if there is an even minute variation from the predicted result, we don't proceed.
Okay.
Just stop, because what happens is Flutter aeroplane can break up in no time, no? Because you just get on YouTube and say Flutter accidents, you see a number of them. I still remember when I was doing the course in France. One day I was sitting on the tarmac, then I found one aeroplane, that naval aircraft, it's called Super Etendar. They call it Super Etendar. So this airplane, when it was on final approach, then I found there is something funny about the aircraft. Then I found that vertical fin is missing. Okay. So then I was curious. Then what was this guy was doing Flutter test, and he was keep diving with Mach number constant, and he lost track. I mean, he forgot to look at the airspeed. Airspeed crossed the limits, and then in no time, the vertical fin got into Flutter. It just flew away. Luckily, he was able to land. That kind of thing. There are plenty of this you can see. Okay. So there is a very famous saying by Theodore von Karman about Flutter. He says some fear Flutter because they don't understand, and there are some others fear because they understand.
Because they understand.
They understand. So what we look for is in an aeroplane, what we see ultimately, what we are trying to do is your cleared envelope is not within Flutter envelope. That's how. So it is a very, very painstaking process, very, very gingerly done, without any kind of a bravado. That's how it is. Okay. So that is what is Flutter. So the another dangerous exercise is what is called store separation. When you release a store, any store released, if it has got a pitch up tendency, there's a very strong chance of it coming back and hitting the aircraft.
Right. And just for the audience, if you can explain what is store, you mean drop tanks, weapons, bombs, missiles, anything, right?
Anything which you slap on an aeroplane, be it a bomb, rockets, or drop tanks, the additional tanks, whatever you slap on, okay, which alters the aerodynamic configuration and the characteristics, and also when it releases, there is a chance of it going and hitting another airplane. So here again, we do a lot of simulation, a lot of this before we do source release test.
Any interesting emergencies that you?
Yeah, there are.
Watch?
Yeah, there were occasions which is led to losing my already balding. one day, yeah, a couple of times I remember. One was we had a double hydraulic utility system failure once. Hydraulic utility system, the hydraulic system, it's a height 1, height 2.
Right.
There are two main pumps, and then we have what is called EMDP, engine mounted driven pump. Okay. Then we have hydraulically driven pump also. There are 4 sources like that. Okay. Then this main system itself, it is segregated into FCS line and utility line. Okay, because FCS line is very critical. If that leaks off, then you lose
flight control for flight control.
FCS stands for flight control. And once what happened was one utility system failed. Say, once utility system there is a leak or something, the content, the hydraulic fluid content from the reservoir, it just starts depleting. It just goes down, and at a set level, there is an isolation valve which just cuts off the utility system, preventing further leak.
Okay.
So that means utility system is not available. Okay. Now and only flight control
system drives or powers what sorts
utility
of
system, undercarriage, brakes, nose wheel steering, that kind of thing.
Oh boy. Okay.
Okay. So utility system one fail came, and immediately if you don't take the gear down, and if it other one fails, So immediately I shouted out, gear down. So we put a gear down, and then other one also failed. If there is a little delay, no way to save that aeroplane, because you can't take the gear down. Okay, so that was one thing. What has led to that was, again, there was a leak. This is a high pressure system. This is like water jet cutting machine. No, like I was told that the HF-24 days, that was the first aeroplane we had a very high pressure hydraulic system. So there were special instructions to the pilot: if there is a leak, don't put your finger there, because you lose a finger, because it's like a knife; it will cut you. So this leak from one system, it cut the other system. No, so that's how it happened. It was it's a touch and go kind of a thing.
Then you had an incident where there was a plastic cover that exploded at Mach 1.4.
Yeah, they see near the where you put the ladder, no, for pilot to get up. There is a small. I don't remember what was inside. There is a plastic disc. Okay, and in flight, what happened was, I was on telemetry, and then was it Polly? I heard him coughing, suddenly, oh, like that, no. Then when he came in, and he said, I smelled something in the thing. So I went to the aeroplane, and then found that this particular disc was missing. Okay. What has happened was, by design, this disc was supposed to have a hole in the center, because then the pressure gets equalized, no.
Right.
So now this particular this thing did not have that hole, and then whatever pressure was trapped inside behind that, it started expanding when the aircraft was climbing. It just popped out, and that thing went into the intake, and then and that is what happened. Then earlier, I thought that there is no. It was not in the drawing. Actually, it was in the drawing, but it was a lab somewhere. No? Then there was no hole there. So once you put the hole there, it is. So yeah, that is another incident. And yeah, there are a couple of other incidents which I remember. One was very interesting. We used to very regularly monitor what is called rundown time of engine.
Aha, right.
You just shut down the engine, and then you start the stopwatch when the and the rundown time is indication of the condition of the rotating assembly. If there is any friction, something, the rundown time will increase. So sorry, other way around. Rundown time will decrease. Okay. So once I found, because I found there is a sudden decrease in rundown time, and these engine tradesmen, the engine group, they went and checked up everything and all that. They said, no, nothing wrong from our side, and now it's within limit, so we'll fly. I said, nothing doing. So I just put my foot down, and then they started, because engine can be your AMAGB, accessory mounted gearbox is coupled to the engine. No, any load coming on that can put a load, and then it can reduce the rundown time. No, so then they started looking at each of the accessories, and they found one of the HMDGs, hydraulically mounted, hydraulically driven generator. No, hydraulic motor driven generator, HMDG. One of the HMDGs is seized. It's not, it was supposed to be a standby power for the FCS channels in case the main fails. And earlier, prior to this incident, we were not monitoring HMDG. What do you call the live? The health monitoring was not done.
Right.
Okay. So then they replaced the thing. Everything became all right, and then they changed the electrical page to monitor the this thing, that this particular incident has led to that. Okay. So like this, there are a couple of incidents. It's very interesting, where I put my foot down, and it had beneficial effects down the line. Yeah, I'm very happy about it.
So, sir, if we can just, I know I've taken a lot of your time, but just take a step back. You've been associated with this project for 20 years. You saw it from even before the first taxi trials, I think, all the way to close to, its final operational clearance. You've seen, all the challenges. You've run an incredibly successful test program with absolutely, no accidents or any such this thing. What are some big picture lessons that you've drawn for our aviation capability, and how do you think we should continue to build on this? Any major lessons you learned from this? How we could do it better the next time?
Okay, that I before that I want to sort of just touch upon one. It's just pinnacle of my test career, aeronautical career, like kind of thing. Just about when I was about to leave like I retired at the age of 60. Then I was on extension. On extension I got a chance to fly a trainer and all that. Okay,
Oh,
anyway.
wow.
Okay, I then what happened was just when we were approaching IOC, initial operational clearance, the controller team, they wanted to incorporate what is called a ALSR, or automatic low speed recovery software. Okay, so they wanted one reliable, redundant climb gradient, aerodynamic gradient information. So they were using the one coming from iron system, because we had only one iron system, inertial navigation system, and they were arriving at this particular thing in an indirect manner. And also for a control system, you need redundant source. So they were stuck for that. Then I suddenly sort of, it came to my mind, this is what was my project in Nepner,
Oh,
climb
wow.
gradient measurement. So I sort of, proposed this particular thing. You use this, and they jumped at it, and that was flying on that. That was a incredibly satisfying kind of a thing for me. And now they have, they are not using this particular algorithm, but I was told by the controller team guys that this algorithm which I developed and which was incorporated during IOC, that is still in the aeroplane as a backup to backup.
Mhm.
Yeah.
Wow.
So that was really
Fantastic.
satisfying.
Fantastic. Wow.
And that IOC also, because of this particular solution which I gave, the IOC came in time with for less cost. In fact, otherwise, they had to putting another inertial navigation system or something. It would have costed money, and huge amount of money and time. So that was really satisfying. Then coming to your this thing, there are some challenges which I sort of uh, which we face. One main challenge is, like, test crew has got a dirty job. I'll say, with dirty job is a difficult job, because we have a fault finding job. We have to find the fault with the system. All right. So the designers tend to develop some kind of an emotional attachment to the system. I mean, you can't, because it's their baby. Okay, and when you point out some defects, they don't like it, they don't accept it. Okay, so this to convince them was like I used to tell them, and my experience is that there are some systems which took the flight test input very seriously and the right spirit. Those systems matured very well. So during my interaction with the designers, I used to say, yeah, system failure is not personal failure. System failure or deficiencies are expected during development stage. Okay, and if you have some kind of a problem coming up during flight test time, you should consider yourself extremely lucky, because flight test is done under highly controlled condition by the extremely qualified and experienced guys. Okay, and you imagine the thing happening in Scotland, which then you can lose aeroplane. So that was one of the issues, then which I try to emphasize on during my interaction with the designers. And then we will have to tell them that we are all here, we have the same objective, to give a safe aeroplane to the user. So that was and then now LCA project has been of such magnitude and depth and breadth. I think we have the capability to develop the state of that next airplane.
70, Roger, report time southeast, connection,
I think we should
midway,
make sure we keep developing such aircraft so that we
Absolutely.
don't lose that capability. I think
Absolutely.
that's very important.
Yeah, otherwise it will be like that after HF24. No, for after 40 years we flew LCA. So yeah, we should not give that kind of a gap, and let us lose the ground covered already.
Wonderful. So you've spent so much of time. I want to thank you for your service. I want to thank you for the time you've taken today to answer all my questions so patiently and so clearly. I really appreciate it.
Thank you. Thank you.
Well, folks, that's all we have time for this week. Join us again next week. In the meantime, sign up for updates at blueskiespodcast.com. There you'll find links to follow us on Twitter, Facebook, and Instagram. You can also write to us with your comments, questions, suggestions, and feedback from the website or to blueskies@prganapati.com. Subscribe to the podcast on any podcasting platform such as Stitcher, Google Podcasts, Spotify, Apple Podcasts, and even on YouTube. If you like what you heard, share it with your friends, give us a rating in your favorite podcasting app, and write us a review. It will help other people find us. I want to give my thanks to Saurav Chordia for our logo and Prithvik for the music. I want to reiterate that all the views expressed here are personal, and this podcast has not been approved by or reviewed by the Air Force, Ministry of Defense, or any branch of the government. In the meantime, stay safe and Jai Hind.